In this module, we're going to go over how to build deeper neural networks using a useful feature in PyTorch called nn.ModuleList. And instead of inputting all the layers manually, we'll create a function that will create a variable number of layers with a variable number of neurons. Instead of looking at the whole class, let's look at the object constructor first. So we'll create an input list, and each element of the list consists of the number of neurons for a particular layer of a neural network. So let's clarify that with an example. So we'll create our model using layers as an input, and we'll instantiate our module list. So let's look at this for loop over here, and let's look at these two variables. We'll start at the first element list and second element of the list and iterate through them together. So here's our list. So for the first iteration, the first element will comprise the number of elements in our input, in this case 2. Similarly, for the first iteration, this list, because it's indexed one above, will basically provide the output size, in this case 3. So we'll have 3 neurons in our first hidden layer. Then we'll iterate to the second iteration, and this list will contain the output size, which is 4. So we'll have 4 neurons, and this element will be the input size, which in this case is 3. So we have 4 neurons requiring 3 inputs. And then finally, for our final iteration, we'll have our number of classes, in this case 3, and this will be our output layer. And then of course our input layer will be 4, and that will be the size of our input. So here's the forward method. And what happens is, this line of code, the variable L, will simply be an index variable, and self.hidden, our module list, which contains the linear objects, will be passed to linear transforms. And for each iteration of the loop, we'll apply the method .linear to each of the activation functions, assign it to the activations. And then when we get to the L-1 layer, because it's a multi-class layer, we'll just apply the linear transform. And this is basically identical to the softmax function. And we'll select the maximum value in the code. So in the lab, we use a spiral dataset. And we can see that usually having more layers gives us better accuracy on the validation data, and our loss decreases faster. And just to note, this isn't always the case, and I encourage you to experiment in the lab. And that's it. So now we're going to go over methods that will help us train these deeper networks better.